take a look that what you understand by the polymer actually. So, polymers form a very important components in our daily life. The polymers are highly useful in domestic, in industrial, as well as in medical field. It's very important for us because they are more durable. They are non-toxic and they are very safe to use. These are the pros or advantages of polymers. So they have very low densities so that the transportation of the polymers is very easy. They possess very good mechanical strength. Some of the polymers contain a very good mechanical strength, and because of it they are very durable and they are resistant to corrosion, which is the biggest disadvantage of any metal, and this is the biggest advantage of polymers. So here, these are the advantages, these are the reasons that why we use polymers so widely. Now, if we talk about the polymers definition, so how can we talk about it? Polymers can be defined as the large molecules which are formed by the linkage of small molecules which are known as monomers. This word came from a Greek language. So in Greek language, poly means many and mer means units. So when many units combines with each other and forms a structure, it can be a chain structure, it can be a branch structure, but when such kind of units came together and forms a long chain, they are referred as polymers. They are available in the form of small beads. The number of repeating units in a polymer chain is known as degree of freedom. This is the basic. When we deal with polymerization or when we deal with any kind of structure of a polymer, at that time it's very necessary for us to understand that if degree of polymerization is high, its properties are really very good. As we all know that, we can take an example of a particular polymer or plastic bag. Now it is compulsory for all the vendors that they have to use a bag which contains 50 or more microns, right? So this shows that 50 micron bag has much more strength, much more durability, and they are less pollutant for the environment. Okay, as you can see in the image, it's available in the form of small beads. You have to melt them and you have to create in whatever shape you want. You can create a bag, you can create any kind of particular thing through this polymer. Okay, it can be colored, it can be non-colored also. Now, after knowing that what you understand by the polymer, here we have to understand that what is the classification or how we can classify the polymers, because it's very important for us to know that which kind of polymers can be used where, because they all have different properties. Okay, here we have a classification of polymer based on different aspects. So the first one is classification of polymers based on its source or based on the sources. So as it can be seen, the first one is a natural polymer. Natural polymers are the polymers which occurs in the nature and are existing in natural sources. Where they can exist? So here the natural sources we can use is plant, animals. Some common examples of the natural polymers that we can take is a protein, cellulose, starch, rubber, etc. We can even take an example of DNA and RNA also, because it's again a polymer of amino acids. So there 4 types of different amino acids are there. They combine with each other and forms a long chain. Although sequence can be differed, but they are one type of polymers. Right? So they are considered as natural polymer. Now, the second type. Which is the second type? So the second type is synthetic polymer. It is exactly opposite to the natural polymer. Here, as you can see, the synthetic polymers are the polymers which humans can artificially create, can artificially synthesize in a lab. It is manufactured polymer. So these are commercially produced by the industries for human necessities, for various uses, for various applications. Here we can take an example of polyethylene, polyvinyl chloride, nylon. They can be a fiber, nylon 6:6, then polyethylene. We have different other types of polymers also, which we can create in a lab very easily. They are known as synthetic polymers. Okay. Now, let's move on to the next one. The next one here is classification of polymers based on its structure. We will classify the polymers depending upon how they are joined with each other here. So the first type that we will have here is linear polymers. What is the meaning of this linear polymers? So these polymers are similar in structure to a long straight chain. A very common example you can take here is PVC, polyvinyl chloride. We can also take an example of polyethylene or polyethylene. What happened that n number of small monomers combines with each other. Now they are generally similar ones. They combines with each other, forms a long chain. This long chain becomes and has a chain structure. So it's referred as linear polymers. Right? Another type is branched chain polymers. So what is the meaning of it? As we can see, the structure of this kind of polymers is like the branches originating at the random points from a single linear chain. Right? A main chain is present, and from that we have different branches came out from it. So it creates a 3D structure. Right? Now here we can take an example of LDPE, which is low density polyethylene. Right? We have another one also which is known as HDPE, that is high density polyethylene. Both of this can be taken as a branch chain polymer. Now, next one or next type is cross-linked monomers. So here what we need to understand, the cross-linked polymers are the most advanced polymers. We have to understood that the first is the linear one, a straight chain. Then second is a branch one, that means small branches will came out from the main chain like this. Okay, now in third one, which is the cross-linked one. What happens in a cross-linked one? A main chain is there, branches are there, these branches are again connected with each other and forms a web. Okay, understood it here properly. So the monomers are linked together to form a three-dimensional network. They have a very good properties. They are very durable. Much more enhanced properties can be observed when we deal with the cross-linked polymers. Okay, we can take an example of bakelite, melamine, etc. They are hard in nature but very durable in nature. Now, the next one, which is classification of polymers based on their molecular forces. We can classify them in 4 different parts. First one, elastomers. Second one, thermoplastics. Third one, thermosetting plastics. And the last one, fibers. These are very important for us because they are classified on the basis of their molecular forces. As you can see here, elastomers are the rubber-like solid polymers. The most common example of this can be in rubber bands, widely used ones. After that, second one, that is thermoplastics. Thermoplastics are the long chain polymers in which intermolecular forces, that is van der Waals forces, hold the polymer chains together. Then third is thermosetting plastic. Thermosetting plastics are the polymers which are semi-fluid in nature but very durable in nature. Okay? Last but not the least, fibers. Fibers are the class of polymers which are thread-like in nature and can be easily woven. They are widely used nowadays. Like we use it everywhere. From optical fiber, another ones also, we uses such kind of fibers. So, this is all for this session. Next, we will have in our next session.